Okay, so this problem is called delete node in a linked list. And when you approach linked list problems, just think about the different ways you can access a linked list or modify a linked list. And just keep in mind, it's just a data structure that we basically will write code to essentially connect one item to the next. So typically in a linked list, you have a reference to the next node, and you also will usually have a head node that you'll start with. Looking at this particular question, write a function to delete a node in a singly linked list. You will not be given access to the head, so a little bit different, of the list. Instead, you will be given access to the node to be deleted directly. It is guaranteed that the node to be deleted is not the tail in the list. That's important because then we know that, if it was the tail, it would be almost impossible. Reason being that, let's think through this a little bit. Normally, when you delete a node in a list, let's say that you were deleting 5, you would start at the head. And so if you're at 4, you would then say for the next node for 4 should just point to 1. So that way, the 5 node ends up essentially just disappearing because you no longer have a reference to it. And then in Java, it would just get garbage collected. But the thing here is that because the node that we want to delete is the one that we're starting with, we can't do the usual way that you would delete a node from a linked list. So we're going to have to get a little bit more creative here. Well, what else could we really do? At this point, what you could instead do is start changing the values of each node until you get to the end of the list. So instead, you could change the value of this current node, which is 5, you could change the value to 1, move on to the next node, change the 1 value to 9, and then at that point you can then just remove the reference at the end of the list, so then you'd end up setting the next node for this 1 node to null. So now that we've established the correct approach, or at least an approach that makes sense, let's go ahead and try to write the code for that. So coming down here, you would essentially want to also have a way to keep track of a previous node, because that's how we're going to remove that node at the very end of the list. So this is a common approach to either have a previous node, a next node, or other temporary pointers. Sometimes you have a fast node and a slow node. So keep that in mind for any time you get linked list problems. So first we're going to say that the previous value is null, and then we'll say while node.next is not equal to null. This means that we have something in the next node that we're going to grab the value of and set our current node's value to that value. So we'll say that the node.val equals node.next.val. And essentially what this is doing is removing our current node by changing the value of our current node to the value of the next node. And then we also need to set our node to the next node. But before we do that, let's store what this current node was. So we'll say that previous equals our current node, and now node equals node.next. And this is very common for whenever you're iterating through a linked list to just say, my current node that I'm working with, or it's some sort of pointer essentially, is now going to point to the next node. And if you're wondering where I had node.next, the class above the problem here has all of the different properties of this list node. So it's just really a class. It's a data structure where this particular class that was designed for us has an integer value. It has a next property, which is of type list node, and then it has a constructor. So if we wanted to, we could also construct a value immediately in list node, but we don't need to do that for this. So this will get us to the end of the list, and then once we are at the end of the list, we then want to make sure that we also remove that last node. So in order to do that, we'll take that previous node and say previous.next equals null. And all that's going to do is just remove that last node. And the reason why we're doing that in this particular case is, like I said, we don't have a way to essentially take a previous node and make its next the node in front of the one we want to delete. So for this particular case, what we have to do is do this changing of values all the way to the end of the list, and then set that last node to null, so that way we have at least somewhere where we can remove a node from our list. And this is the way we're going to do it. So when I go ahead and click submit, you'll see that it was accepted. And then as far as time, it's going to basically be big O of n, because you're going to iterate through the entire list. And your space complexity is constant because you're not adding any extra space other than this previous list node reference that you're creating, but that is considered constant space. So that is all there is to this problem. If you have any questions, let me know in the comments below. And if there's any questions you particularly want to see in future videos, please let me know as well. And also, please take a moment to like and subscribe for future content. Thank you.